And once it does, then we'll talk a little bit. So any questions on any of the stuff we've been doing in this section with verifying trig identities? Anything from yesterday that you want to go over before we switch gears, move on, do some different things? Last chance. Sort of, not really. You can always ask, but I am going to move on a little bit. So, you good? Okay. Okay. 5.3 is solving trig equations. And, you know, sometimes it's just sine and you just inverse sine, or sometimes you have to factor. Okay, I'll factor. Or sometimes this or that. It's just combining trig stuff with algebra. And in my eyes, you already know how to do almost all of that. And so I'm not going to spend a whole day doing anything like that. I think that if you want to be sure you're feeling confident, we've done it already, solving trig equations. You can just look through the section. I'm not going to sit here and reteach it to you, though. I want to try to value as much of the time that we have together as we can. And so I personally am just going to pass over 5.3 and let you browse it at your leisure if you feel like it. It's not something that I'm going to test you on. It's not something that you would find a whole bunch of brand new stuff in. You already know how to do it. And I would rather move on to something that I know is going to be brand new, which is going to be 5.4. Okay, so 5.3, check it out if you want. That's up to you. 5.4 definitely does some things that we are unable to do without some help. And so have your trig cheat sheet out handy, or at least write down what I'm about to write down, because there are some identities that we just haven't used yet. And I don't know that identities is really the word. It's actually more of a formula. If you look on that same page where we find all of our identities, tangent ones, reciprocal ones, and Pythagorean ones, what you'll see is that there are a whole lot more, right? Now, there's no way that we'd ever get to all of these, and that's okay. But I did want to talk through just a couple things with you, just so you can see it. And then I will focus in on 5.4 on one of those small sections, okay? So right below the Pythagorean ones, they kind of explain which functions are even versus odd. And they're either one or the other, okay? Not something we really have to know. You just have to remember that even functions are symmetric over the y-axis, and odd functions go through the origin. So that's that. The periodic stuff, it just reminds us of what the period is for each of those functions, right? Sine and cosine, and the reciprocals, you see that theta plus 2 pi n, right? The 2 pi being the period. And then for tangent and cotangent, you see it just is theta plus pi n. And of course, n is an integer there. Okay, whenever we use n, if we don't specify, n is a member of the integers, okay? I'm gonna skip double angles just for a second. You got degrees to radians down there at the bottom. Cool. So I'm going to come back to double angles. That's actually 5.5. What we get to in 5.4 is actually on the right-hand column of that trig cheat sheet. So if you look at the top of that second page, I think it's the second page, and you look at the right-hand column, you see half angle formulas. That is kind of that go together with the double angle formulas. And I'll talk more about that in 5.5. What I want to focus on today is the one right below half angles, the sum and difference formulas. And they have ones that work for sine, for cosine, and for tangent. What I want to focus on is just sine and cosine. Okay, it's the same idea when you apply it to tangent. You just plug in your numbers and just kind of go from there. Sine and cosine is just a whole lot easier because you see there's no fraction that gets created initially. And the values that I'm going to be using are just unit circle values anyway for those numbers. And so what I want you to have, either you write it down, I'm going to write it down up here just so I have something to look back at, or you just have that trig cheat sheet out. I want you to not have these necessarily memorized, but I want you to understand how we're going to use them. So I'm going to write them down just so I have them to look at, so I don't have to keep looking back at my screen here. Okay. So we've got what are called sum and difference formulas. And what this allows us to do is finally find exact values for sine and cosine that maybe aren't exactly at unit circle values, but instead they're at the sum of two unit circle values or the difference of two unit circle values. So like, for example, so what I'm going to say is if alpha and beta, so alpha just kind of looks like, is that backwards? Did I draw that backwards? I did. Alpha, so right. Am I backwards? Why am I thinking so weird? Did I have it right the first time? Sorry. Yeah. Alpha kind of looks like the letter A, but kind of like a goldfish too, if you're going to draw that out. And beta. Now, we're only going to use unit circle values. This works for all of them, but we're just going to do it this way. So our angles in radians from the unit circle okay. Now this works with all of them, but I can't really know what sine of an angle is going to be if it's not a unit circle value. So I'm going to just focus us in on that. We've got some ways to put them together. So let's say like alpha is 30 and beta is 45. I will do a specific example with that. I can add those together. 30 plus 45 is 75, right? I can find the exact value of sine of 75 degrees, right? Pi over 6 and pi over 3, or pi over 6 and pi over 4, right? If I can add those together, and so in radians is always nice, but guess what? Degrees is cool too, okay? And I'll probably even stick with degrees just to make it simpler for us in a short day like this. If there are angles from the unit circle, so radians or degrees, either one, as long as they're from the unit circle, we can add them together and I can find the exact y value or the exact x value versus sine or cosine at that exact spot. So, go to 75 degrees. Well, it's the y value is bigger than radical 3 over 2, but it's not quite 1 yet. What is it exactly? I can find that exact measurement. And there's formulas that allow us to do this, which is really, really nice. So you've got two formulas, okay? We've got a sine one, okay? Alpha, and it could be plus or minus beta. That's why they call it the sum and difference formulas, because they're all kind of combined together. And we've got a cosine one, okay? Alpha plus or minus beta. You see that we're using alpha and beta here because I don't want to use theta and theta. They're going to be different numbers. Because if I took 30 plus 30, well, that's 60. It's already unit circle. 45 and 45, well, that's 90. That's already unit circle. I need to add numbers together that don't create another unit circle spot. All right, so 30 plus 60, well, that's 90. I don't need a formula to do that. I just do sine of 90. It's like the 30s and the 45s, or the 45s and the 60s. It's one of those combinations of like a 30 and a 60 as anywhere around the circle and a 45, okay? And we've got two formulas that we can just plug in. And I'll show you how we do it, okay? The first one for sine, okay, goes like this. Sine of alpha times cosine of beta. So we're kind of individually finding the sine of the first angle, the cosine of the second one, and then we'll multiply them together. And then plus or minus cosine of alpha, sine of beta. Okay, so those will be multiplied together. And you can see that because this is written as plus or minus, and this one's written as plus or minus, that if we're doing adding, right, if we did 30 plus 45, then we would choose the plus here as well. So if this is addition, this is addition. If this is subtraction, if we switched it and did 30 minus 45, then this would also be subtraction, which is why the signs are the same, plus or minus, okay? With cosine, it's a little bit different, okay? It's cosine of alpha times the cosine of beta. And now the sign has to switch, okay? This one would match. This one is minus or plus instead of plus or minus to remind us that if you are adding two angles together, then we are going to subtract right here. If we're subtracting two angles, we will add right here, which is why that sign is flipped upside down. And then sine of alpha times the sine beta. Okay. So those are our two formulas. Okay, and those are the only two things that I want to focus on here in 5.4. Okay, sum and difference formulas. And I just want to work through a couple examples with you, just so you can kind of see them in action. And you're going to see that there's really not that many options for putting these numbers together and getting a whole bunch of different answers. Really, we're finding the spots that are basically reference angles of 15 up or down from the x-axis, up or down, depending on which quadrant you're in, or reference angles of 75 up or down from the x-axis. That's really the only kind of combinations I can make. I can go to 15 degrees, 75 degrees, 105 degrees, 165 degrees, 195 degrees. That's really the only combinations that can get us there, okay? And so let's do one, okay? So I'm gonna leave this up over here, but I am gonna move us over to the next board. I just wanted to write stuff down. I've been on the projector for a while. So these formulas are sitting right on that trick cheat sheet, second column, second page, I think. But the other thing you're gonna want to have out handy in case you don't have the unit circle super stuck in your brain is the actual unit circle, right? You're gonna want that for sure. Will I be able to take a photo of the board once you're done uploading to Canvas? Absolutely, happy to. Okay, sweet. All right, so let's just do one. All right, I'm just gonna make it up. Call it number one. I don't know. I'm just making it up. Sine of some combination of two angles that don't add up to a unit circle spot, but separately are, right? So let's do, and I'm gonna stick with degrees because just to make our life just that much easier, 30 degrees plus 45 degrees, okay? And what's nice about this formula is that it's set in stone, that I just have to kind of rewrite it using that other side of the formula and then evaluate each one separately. Okay, and so that's what I'm gonna do. I'm gonna work to the right here, and I'm gonna say, okay, I've got a formula for the sum of two angles for sine. So like for me, alpha is 30 and beta is 45, okay? And what the formula tells me is that I should be able to do sine of 30 degrees, right? Sine of alpha, cosine of beta, so cosine of 45 degrees. And because with the sine, it's plus or minus inside and plus or minus on the outside, I just match the sign, plus. Cosine of 30 degrees, sine of 45. And what this allows us to do is find a perfect answer that we otherwise wouldn't be able to find. Okay? And that's what a lot of those things are doing. All of these formulas that we're probably not going to get to really just kind of break it down into a way to allow us to find some of those inside missing pieces a little bit. You get some double angle formulas, some half angle formulas, and you just plug them in. And you just let the math kind of take care of itself. Now from here, I'm going to work down just so I can kind of use my space vertically. So you can see what's similar. And I just jump into my unit circle, and I've got 1, 2, 3, 4 evaluations that I need to do. I just find the x value or the y value at each of those measurements. And of course, this would work just fine with radians. It's just nice and easy when we're looking at degrees. Cool. So sine of 30 is 1/2. Cosine of 45 is radical 2/2. And I just drop in those numbers. Cosine of 30, radical 3 over 2. Sine of 45, radical 2 over 2. And then I just simplify the whatever I've got, right? So I drop in my numbers, the 30 and the 45, whatever my alpha and beta happen to be, and I just kind of evaluate each one. Now I need to put these fractions together and just make it look as simple as I possibly can, okay? And so when I'm simplifying numbers, I just order of operations. So I have to do the multiplication part first. So I'm going to multiply those two together separately and see what I get, okay? So 1 times radical 2 up top, so just square root of 2 on top. And then 2 times 2 across the bottom, so that's 4. And when we're multiplying radicals together, we can just multiply the radicands, right? So you got square root of 3 and square root of 2. Okay, square root of whatever 3 times 2 is, which is 6, over 4. And now let's just make one fraction. And what's really nice about this whole process is that no matter what we're doing, all of our unit circle values that we're going to see in general will have that dividing by 2. And so when I multiply them together, the denominators are both going to be 4. And so maybe I don't even have to worry about creating common denominators. They're already there. And I can just write it as the square root of 2 plus the square root of 6. That is exactly the sine, whatever the sine of 30 plus 45 is, whatever the sine of 75 degrees is, right? Open up to 75, there's your y value. Done. That's it. Okay, a really nice formula that can get us that perfect y value for an angle that I really don't know an answer to. Okay. Sweet. Let's do another one. What about sine of, what if we did, let's see, it's got to be like a multiple of 30 or 60 and then a 45. It's got to be some combination of those two. So what if we did like, I don't know, man, what if we did like, Ooh, I got one. What if we did 120 degrees minus 45 degrees? Let's try that. Okay. So still sine, so I'm still using that same first formula, but now that it's subtraction, I just have to make sure that my sine, my plus or minus, right, I picked the right one. I'm gonna always pick the same one. Okay, so sine of the first one, so sine of 120, cosine of 45. And remember, because this one has plus or minus on the inside and plus or minus on the outside, we just match whatever that symbol is. Cosine of 120, parentheses are optional. I drew it in there, but I'll stick without it for now. And I'll put the multiplication in there. And then times the sine of 45. And these are like proven formulas. They went through the whole process of making sure that no matter where you're at, this one's going to work. So we can count on it. Now we just have to plug it in and see what we get. And so I just jump into my unit circle, either in my mind or on paper, right, sitting right there. And I just find y value at 120, x value at 45, x value at 120, y value at 45, right? Because cosine and sine are x and y. And so, okay, sine of 120 degrees. So I go over to 120 y value up there, radical 3 over 2. Cosine of 45, radical 2 over 2. Minus. Cosine of 120, okay, so that's negative 1/2. I know I have these back-to-back subtractions. That's okay, we'll deal with that here in a second. Times the sine 45, okay, that's radical 2 over 2. And then I just simplify, right? Multiply things together, and then we'll hopefully either have common denominators or we'll just create it so we can make one fraction. Okay, so radical 3 times radical 2, still radical 6 over 4, right? Because we're multiplying, so multiply the tops, multiply the bottoms. All right, 2 negatives make it positive, so I'll just put the plus sign now. Save myself a little bit of trouble. And then radical 2 on top, and then 4 on the bottom. Nice. Okay. So already have a common denominator, so I can just leave it all over 4. Square root of 6 plus the square root of 2. Ta-da. Piece of cake. Do you notice anything about those two problems that we just did? Do you see anything that kind of stands out? Look at your two answers. Radical 2 plus radical 6, all over 4. Radical 6 plus radical 2, all over 4. What do you notice about these two answers? I know they're written in a different order, but
they're the same.
They're the same. Why? Why am I getting the exact same value for two different setups?
120 is a multiple of 30.
True. So we're getting similar values, right? But remember, like sine of 30 and sine of 120 are different spots. Sine of 30 was 1/2. Sine of 120 was radical 3 over 2. But yeah, you're right. We need like a multiple of 30 or 60 and a multiple of 45 if this is even going to be necessary. Because if it's two multiples of 30, then we'll just get a multiple of 60. And if it's two multiples of 45, then we'll just get 90s or 180s or something like that. But why are we getting the same, like equivalent answers for two different setups?
Both their sums are 75.
Yeah, 30 plus 45 is 75. 120 minus 45 is 75. Both of these problems, we're asking the same question. What is the sine of 75 degrees? And so that's the kind of question they're going to ask. They're not going to give it to us usually broken apart as a sum or difference. They're going to write it as a single angle. And it's going to be up to us to figure out an alpha and a beta that we can write separately. So like I'm going to make this leap. Like, okay, find the sine of 75 degrees. The first thing I'm going to do is rewrite it as either a sum or a difference of two angles that I know, like 30 and 45, like 120 and 45. Some kind of combination like that to get you to a spot where we can just plug it into a formula, okay? But you can see that it doesn't matter which way we go, we're gonna find equivalent answers. So just find a pair that works and get there, okay? And there's a bunch of them. These are not the only two. I could find a couple different ways to find how to add or subtract two unit circle spots and get to 75. All right, let's do a pair with cosine, but let's start it like that so you can see what that looks like. So I'm back over here. All right, so call it one number 1 and number 2. So let's call this one number 3. So cosine of something. How about I wrote down some options so I knew I had some choices. Let's go 165. 165 degrees. That's how these questions are going to start. They're going to make us figure out, okay, can I come up with a pair of angles from the unit circle But I could add together to get to 165 or subtract. Doesn't matter. The answers will still work. That are going to work. And this is where I want to lean on you. Do you have a pair that you think we could put together to get to 165?
120 plus 45.
Perfect. Let's do it. 120 degrees plus 45 degrees. And the order doesn't matter. If you said 45 plus 120, still would work. Okay, now let's use that formula. Okay, and so we want to kind of pick an alpha and pick a beta. And usually we say, okay, the first was alpha, the second one's beta, and we just kind of jump into it like that. Okay, so the first one is cosine of alpha, cosine of beta. So cosine of, and if you like the parentheses because it feels better to draw them like that, cool. Cosine of 120 times the cosine of 45. And remember, with the sine one, we kept the sign the same. If it was plus, it was plus. If it was minus, it was minus. With cosine, it switched. That's why your plus or minus goes to minus or plus. So this was addition, right? We had a sum, so this becomes subtraction if we want to get the right answer. Okay, and then it's sine of alpha, sine of beta. So sine of 120, sine of 45. Working with degrees just makes it a lot easier, right? Because I don't even know what 165 is in radians, but it would have to be, you know, what is that? Geez, off the top of my head, I don't even know this stuff anymore. Is that 2 pi over 3 plus pi over 4? Yeah, tricky to see that combination when it's in pi. So I like to stick with degrees when we work through this, okay? And now it's just the same thing. Once you pick your right numbers, which can really sometimes be the only tricky part, it's just making sure you've got a unit circle in front of you or stuck up here where you can find those x and y values because they're all really nice unit circle spots. Cosine of 120, so I open up an angle of 120, so that should be negative 1/2 times cosine of 45, okay, radical 2 over 2, minus sine of 120, okay, radical 3 over 2, times the sine of 45, square root 2 over 2. Multiply the two fractions together, and then combine them to one. Negative radical 2 over 4, minus radical 6 over 4. And so if I put this all over 4, you've got a couple different ways to write it. And I want to show you both because sometimes some answers will be written one way and sometimes it's written the other way. Maybe you hold on to the negative, negative square root of 2 minus the square root of 6, and the negatives all exist on top. A lot of times that's a pretty perfect looking answer. Okay, but what you might notice is that because you do have a negative everywhere up top, but especially as your leading coefficient, right? You've got a negative sitting out front. A lot of times what some people like to do is pull that negative out in front by factoring it out completely from the top and calling it the square root of 2 plus the square root of 6. And now, for me, I'm happy either way. Whatever you want to call it, I'm good, so you don't have to write both. But pick one, pick whichever one you like better. Personally, I like this one. I think a lot of math teachers would, because it tells you that your fraction is negative. Right? Your number exists to the left of 0, wherever that happens to be. Which makes sense because cosine in the second quadrant is negative. And I want to make sure that I recognize that right away. And it also really nicely connects. I mean, look back at the two that we just did. The sine of 75 degrees is exactly the same number, just opposite sign, as the cosine of 165. Okay. Why? Because they are 90 degrees apart, right? Which is exactly that phase shift that we've been seeing when we've been graphing these. Cool? Okay. Here's what I want you to do right now. I want you, for number 4, this will be the last one, find a different pair of unit circle values that you can either add or subtract and get to 165. And then do it. See if you can get to either one of these same answers by doing the exact same thing. Okay. Try that. See if you can come up with a way to either add or subtract, either one, 2 unit circle spots of something degrees, plus or minus, something degrees, and then do it.
210. 210.
Yeah, I want everybody to try it on their own.
Oh, my bad.
It's all good. See if you can do it your own. Find a pair that works, and then do it. But it sounds like you got one, so that's good. And I like that you chose subtraction too. That'll be kind of fun. You came up with that pretty quickly. That's awesome. See how many different ones we can get. When you've got one, drop it in the chat. I want to see how many different ones we can do. And this way, if you don't want to look, because you haven't gotten one yet or you're still working, then don't peek yet. But drop your 2 angles, and you don't have to put degrees or anything. You can just say 120 plus 45. Or I heard a 210. Wonder what that one was. Drop it in the chat. Let us know what you got. And then finish it up. If you got to there, then you're good. Oh, nice. Okay, so we got 225 minus 60. Oh my goodness. 135 plus. Oh, I'm saying it out loud. That's probably not helping. Nice. Nice. Good. Nice. There you go. All right. 3 really easy choices. Okay. 2 of them subtraction, 2 of them addition. Usually there is a nice balance like that when you start to get into second or third or fourth quadrants. First quadrant stuff is kind of hard. But really, there's a lot of different ways that you can put them together. You can use negative angles. You can use all kinds of stuff. So finish up. Hopefully that this worked out nicely for you and you got yourself to one or both of those answers. Again, I like the one where the negative comes out, but either one is good. I'm happy either way. Okay. Now, as you finish putting that all together, let me talk to you a little bit about these next couple days. Okay. Here's my thinking, and I will write this up formally on Canvas so that you don't have to remember all the things that I'm about to tell you. Okay, number 1, you do not have to submit any of this stuff on Canvas for work for the day, okay? So that's number 1. Number 2, I've got some homework grading that I'm gonna catch up on, the review, and then your 5.2 stuff. So I will do that today, tomorrow, to make sure that we're kind of all caught up. Number 3, the grades are in for your test from last week. If you have questions about the test, your grade, if you want to look at it more closely, talk it through, I'm happy to do that one-on-one. Just give me a shout and we'll set up a time to do that. Either face-to-face or we can just message back and forth, okay? So that's number 3. Number 4, I have made the decision to not formally require a Chapter 5 test, okay? Instead, what I'm going to do is give you the option of like a take-home one this weekend, okay? If you want to, take it, okay? If you don't want to, don't. I will have a spot in the grade book for Chapter 5. I might even just call it a quiz, maybe not out of 100, maybe it'll be more out of like 50, maybe we'll do something like that. Completely optional, okay? If you take it, whatever grade you get goes in. If you don't take it, it just stays blank and it doesn't help you or hurt you, okay? I will give you the choice of what you want to do, okay? It will be, kind of all of the stuff that we've done here in Chapter 5, but not a lot of it, right? It'll be mostly just trig identities and sum and difference. That'll be it. So it'll be relatively short. So if you're feeling pretty good about it, maybe it's a chance to get another grade in the grade book. Even if you did really, really well on this last test, calculus is coming. And so like, oh man, I got a 98 on this last test. I don't want to get a 92 and bring my grade down. Well, guess what? If you get a 98 and then a 92 and then your next test is a 75, that 92 is going to help. Okay. So that's your choice though. I will give you the freedom to think it through and let you make that decision. Okay. And you will have, I will send it out as soon as I can put it together, and then you'll have until Sunday to get it done. Because what I've decided is calculus begins on Monday. Okay, we are going to begin calculus on Monday. So here's what you need to do. Sometime between, I don't know, I'm gonna have to make a bunch of copies. Sometimes between this afternoon by 3 o'clock, like I'll have it, geez, it's a busy day with the Wednesday stuff. So certainly tomorrow, how about that? Starting tomorrow morning, there will be copies of the guided notes for our first unit for calculus sitting at a table across from the security kiosk, across from Leonard and Deb. There's a couple tables set up where teachers have copies laid out, okay? There will be a big old stack for all of you to come pick them up, and I highly suggest you do, okay? If you don't, you're gonna have a lot more writing ahead of you and you won't be able to absorb the calculus as well. Okay, so starting tomorrow, so you have tomorrow or Friday, you can drop in and pick up those copies, okay? And once calculus begins, we're gonna put a hold on trig until I get a copy of the college trig final from CU, and then I'll fill in any gaps that we need to in May. I know for sure that we'll have to do some stuff from Chapter 6. I know for sure that we will have to do some stuff from Chapter 9 in terms of polar graphing, which is so cool. You'll love it. And I just want to save that for May. Okay, so what does that mean for us for the rest of the week? Well, what it means is when I send out that test for Chapter 5, feel free to look at it. Use your notes. Work through it. It's take home. Okay, I want you to do well. I just wanted to give you a chance to formalize your learning and see where you're at. Okay, I hope that most, if not everybody, takes it and you kind of view it more of a culminating review where you can get lots of help from me. I don't want you really to work on it with anybody else, but I would happily entertain lots of questions if I can help you. Okay, I want it to be kind of a grade boosting thing because I know we have put in a lot of work over these last few weeks. And so here's my plan, okay? When you come to class tomorrow, okay, you will drop in, you will say hello, and then you will leave. Okay, I am basically giving you the next 4 days off. Okay, you deserve it. Okay, you deserve to focus on other things. You deserve a break, okay, to help your mind kind of reset, refresh, and get ready for calculus, okay? So take that time and enjoy it, okay? I still need to take attendance tomorrow face-to-face, so just pop your head on for like 1 minute, like see what time you drop in right at the beginning. It'll, 8:35, okay? And then leave at 8:36 or 8:37. Or stick around and ask questions if you have any questions about today's stuff or trig identities, because those will be the 2 things that'll be on your test that I will hopefully send out sometime tomorrow. I want to get it to you as soon as I can so you can pick the times when you want to work on it, okay? But you will not have any homework. I will happily give you some more practice with stuff like this tomorrow so that you feel a little bit more confident going into the test. I know we only did 4 of them, but really there's not much difference, right? They're all pretty similar kinds of questions, and you'll see really similar looking answers, right? Because there's only a handful of spots on the unit circle that we're looking at. Okay, so I wanted to give you all of that hard work I think you deserve. So enjoy some time off from math from now until Monday. Choose to take the test this weekend, tomorrow, Friday, Saturday, Sunday, if you want. And let's go into Monday with a clear head and ready for a very different approach to what we've been doing. So, but you definitely want to come in tomorrow or Friday and pick up copies. Because like the stack's going to be pretty tall. You won't miss it because there's 50 something of us between the 2 classes. And I'm giving you, I think, I have to look through it, but I'll probably give you the entire first chapter of guided notes, okay? So it's all in one spot. So it could be kind of thick. I haven't decided. I might break it up because fingers crossed we come back kind of soon. So I don't know. I'll look through it. I don't want to kill too many trees all at once. Although that's how many trees I'm going to kill anyway. But it just drives me crazy to use that much paper. Okay, so that's my plan. Okay, number 1, don't submit anything for today. Okay, if you want to talk about your test, let's do that. Let me know. Otherwise, wait for a test to come out in the next day or so. Take a look at it, see how you do. Do it yourself, just you, but ask me questions. Okay, I want you to work with me. I don't want you to work with anybody else, but you can use notes. You can look back at stuff that we've done. And come and pick up some copies, okay? Sound good? Yay. Okay, you guys are awesome. You are free to go, and I will put these pictures up on Canvas right now. Give me like 5 minutes, and I will see you tomorrow briefly, and then I will send something out on Friday so that I can take attendance right to set regular remote form so I can just make sure that you woke up and click some buttons for me, but I won't, we won't do any more math unless you want to until Monday. Bye guys, thanks, see ya.
Thank you.
Yeah.
You're welcome.
Yeah.
Thank you. Have a good day.
Thank you.
You too.